Hi, this is a GMAT question from gmatquestions.org. If k and p are constant and s and t are non-zero roots of x squared plus kx plus p equals 0, is the quotient s over t less than 0? Statement number 1, p is less than 0. Statement number 2, k is less than 0. This is called a quadratic equation because it's raised, the highest power is 2. We have an x squared here and we have an x. So it's a quadratic equation and we need to learn the rules that govern quadratic equations. We're going to rewrite this equation. Now, since the s and t are the roots of the equation, this must be true. It must be true that x minus s times x minus t is equal to 0. Those who are familiar with factorization know this. Okay? And this equation is true only because the coefficient of x squared is equal to 1. If you had something here that is not 1, like for example 2, I will not be able to write this exactly like this. I'm going to have to adjust it here. Okay? So as long as the coefficient of x squared is 1, we can write this. This is true. Now, there are two other things that are true, and I'm going to mention them here because it's very important. That P is the product of the roots. This P here is the product of the root. So, if you want, P is equal to S times T. Also, this K is the opposite of the sum of the roots. Let's write that down. B, K is actually the opposite of the sum of the root. The sum of the root is S plus T, and K is the negative of that. So these are two very important rules. If you don't remember them, they are right here. In high school we learn this, and this can be important. Now, do not confuse S and T with the numbers you actually choose when you do a straight factorization. Let me give you an example. If you have, for example, x squared plus 3x plus 2 equals 0, when you factor this out, you have x plus 2 times x plus 1 equals 0. 2 times 1 give you 2, as you can see, that's the product, and 2 plus 1 give you 3. But 2 and 1 are not the roots. The actual roots are x equal negative 2 or x equal negative 1. So be careful when you do the factorization. What you see is not really the root. It's the opposite of the root. As you can see, x times, let's put x1 here if you want, x2. x1 times x2 is still equal to 2. But the sum x1 plus x2, which is negative 2 plus negative 1, which is negative 3, is actually the opposite of 3. Okay? I hope that I have cleared the confusion here, because sometimes we mix the two. In the factorization, you tend to see the opposites of the roots. Here we don't have really that problem because you have a minus here. We have a minus and another minus. So when you solve this, you're going to have x equal s or x equal t. Okay? So be careful about that. I hope you can study this and see the difference. Okay? What really you need to, you want to make sure you don't make a mistake about that. Great. So now if we attack number 1 here, Number one, we are told that P is less than 0. So P being equal to S times T is less than 0. So S over T has to be less than 0. The product and the quotients of two entities, two numbers, have the same sign. If st is negative, s over t will be negative. If s times t is positive, s over t gonna be positive. Now, for 0, when s is 0, s over t, the product st gonna be 0 obviously, and s over t gonna be 0. The only time where they really don't have the same sign is when t is equal to 0. When t is equal to 0, the product st is equal to 0, but the quotient s over t is undefined because we cannot have 0 in the denominator. That's the only exception. In any other case, the product st and the quotient s over t have the same sign. That is important. Okay, so what does it mean? It means here that number 1 is sufficient to answer the question. Okay? Number 2, we are given that k is less than 0. But I must remind you that k is equal to negative s plus t, as you can see here. So, s plus t has to be greater than 0, no problem. Okay? I hope you can see that. But if the product s plus t is greater than 0, does it help us know the quotient? If the sum s plus t is greater than 0, does it help us know the sign of the quotient? I don't think so. Okay? If s, for example, just to make it simple, equal t equal 2, for example, then s plus t is equal to 4, which is greater than 0. Okay, now, n s over t is equal to 2 over 2 equal 1 greater than 0. However, if you choose s equal maybe 3, t equal negative 2, s plus t, the sum is equal to 1 greater than 0. But s over t is equal to 3 over negative 2, which is obviously less than 0, this quotient. So as you can see, in one case, the quotient is greater than 0. Another case, the quotient is less than 0. So greater than 0, less than 0. Okay? And in both cases, we did respect the statement number 2. Okay, k less than 0, which means s plus t greater than 0. So as you can see, number 2 is not sufficient. Number 2, not sufficient. So in data sufficiency terms, the correct answer is A. 1 sufficient, B not sufficient. Sorry again, 1 sufficient, 2 not sufficient. The answer is A. Let's write that down. A is the correct answer. And that's it. I hope you've been able to follow me here. You've learned a few important concepts of the quadratic equation. And make sure you remember this. This P here is the product and the sum, because trust me, it can really help. Sometimes it can really help. So remember that Remember this factorization I did here. Remember the difference between this type of factorization, at least when you have the roots and when you have the opposite of the roots. Okay? Having said that, thank you very much for watching. This is a GMAT question from gmatquestions.org.